My report is about paper review on fault analysis. So, introduction. So, most common topic on research is about fault analysis. Because it involved the because it is fault analysis is the important consideration in power system planning, protection, and equipment selection. So when a fault or a short circuit occur at some point in the network, normal operating condition of the system are upset. So if the fault is persistent, severe loss of load, property damage due to fire explosion, and steep economic losses can arise as undesirable consequence. So therefore, correct modeling of component and correct fault analysis in power system and transmission are critical to ensuring safety, reliability of the system. Thus, analysis during this condition drawn attention of the researcher. Number 2, readings and literature on the given topic. So, mayroon tayong tatlong research paper na ang ginawa natin ng paper review. So, related 3 topics. So, yung una is real-time fault analysis of transmission line using wavelength multi-resolution analysis based frequency domain. Real-time fault analysis of transmission line using wavelength multi-resolution analysis based frequency domain approach is experimental based research which aim to detect fault in real-time fault analysis and location fault in distribution network. So, ito yung yung block diagram noong kinandak nilang experiment. So, ito ay gumawa sila ng setup. So, ito yung block diagram. So, gumamit sila ng 3-phase transformer which is star. So, nakakonect tong transformer na to sa transmission line o sa transmission distribution system. So, ang purpose nito is step down niya yung voltage. So, from 200 extra high 200 kV extra high voltage. So, step down niya into 440 to 20 volts. Which is yun yung operating parameters ng system na system. So, ito na yung system parameters na setup nila. Then, gumamit sila ng isolation transformer. So, para protection. So, in case magkaroon ng fault sa transmission line, so yung isolation transformer is para maging protection. So, safe pa rin yung setup nila dahil dito sa isolation transformer. Next is pupunta siya, so tingnan mo lang yung arrow, pupunta siya sa data acquisition module nila. So, meron siyang module na current input module. Ito yung code niya, 9227 current input module and 9401 digital I/O module. So, ito, yung purpose naman ito is convert niya yung data and mga signal into a block diagram so that etong CPU i-convert niya yung input signal into block diagram na mariread ng CPU. Then meron siya computer monitor with a LabVIEW virtual instrumentation. So, ang makikita dito yung sa monitor niya ay yung fault identification, three-phase current waveform, indication of ground fault and fault classification, then current waveform in each phase. So, ito yung mga display sa monitor front panel. While meron pa siya, aside from mga display, meron din siya naka-indicate na mga block diagram. So, DWT. Then, yung extraction feature of fault A, fault B, fault C. Papuntang fault detection algorithm. Then, pupunta siya sa trip signal and fault classification algorithm. So, dito, pinakita yung process ng setup ng experiment na ginawa ng researcher. So, this setup is used for real-time transmission line fault analysis using wavelength, MRA, and LabVIEW software. It incorporates a power supply with a step-down transformer and isolation transformer, three-phase hybrid transmission line model with 4-pole contactor and DAQ, so data acquisition system in conjunction with personal computer with LabVIEW software. So, ito naman yung mga components niya. So, diniscuss dito yung mga usage. So, a three-phase auto transformer with a rating of 440 volts down to 0 to 470 volts AC used as a variable input supply for the hybrid transmission line model. The output of the auto transformer is given to the step-down transformer of 440 to 20 volt phase-to-phase voltage, which is used for reducing operating voltage of the laboratory hybrid transmission line to 20 volt. A 4-pole 230 volt contactor is connected after the isolation transformer, which acts as a circuit breaker for the hybrid transmission line model to isolate the transmission line as soon as fault is detected. So, ito yung purple. So, after ng isolation transformer, ang next niya is purple contactor, which serve as circuit breaker. So, protection doon sa setup nila. So, sundan mo lang yung mga arrow kung saan siya papunta. So, data acquisition system is a three-phase analog current signal from the laboratory hybrid transmission line model are obtained at 0 kilometer from the sending end. These analog signals are converted into digital form and sent to the personal computer using NI CDAQ 9178 chassis. The block diagram of the DAQ is depicted in. So, ito yung data acquisition system. It's kino-convert niya yung signal into a block diagram para ma-read noong computer. So, ang next research na i-review natin itong detecting instant of multiple faults on the transmission line and its type using time frequency analysis. So, ito, gumagamit siya ng phase monitoring unit para sa pag-read ng mga signal. So, may monitor siya. So, pakita natin mamaya. This study presents protection scheme for multiple fault detection at bus line and its type in a wide area network. So, if a fault occurs on a line followed by another fault at the same or different line, before the clearance of former fault, so the proposed scheme is capable of detecting multiple fault events. So the scheme applies process signal information for its time frequency presentation using smoothed pseudo-Wigner wheel distribution followed by Hilbert transform and calculation indices to interpret the fault events. So itong research na to is computation-based yung ginawa ng researcher. It is shown that the faulted bus and faulted line time instant and type of faults can be easily identified with low computational burden. The scheme is validated on the signal simulated on Condor model IEE E39 bus system and conditions bus system and verified with signal on real-time digital simulator for different fault condition, fault resistance, and fault location on the line. The scheme can be successfully applied on signal available from phase measurement unit for wide area network protection. So, ito naman yung block diagram. So, ito yung pinapakita niya yung process. So, from phase monitoring signal or V&I phasor. So, yung unang step niya, so kung titingnan niyo yung arrow, so i-calculate yung mean and voltage deviation. So, yung M, so represent kung anong phase siya, ay anong bus, yung M represent yung bus number. While yung K, yan yung bus. Kung anong bus siya. M, so tandaan natin yung M, yan yung phase. Kung anong phase, then yung K, yung bus. So next is yung mean voltage deviation, NK, must be greater than 0.015. So pag ang mean voltage deviation is greater, so ang mangyayari, mayroon siyang fault. So therefore, ang next step niya is eto, yung pababa. So itong yes. So pag greater, so mapupunta sa yes. While pag no, pag less than naman 0.015 yung mean voltage deviation. Pag less than, ibig sabihin walang fault. So kung titingnan niyo yung arrow, so magsiselect siya ng next segment. So may end na yung process. So pag walang fault. Pero pag may fault, punta tayo sa baba. So a fault occurred. So mean voltage deviation, J, for example, yung J is equal sa max mean voltage deviation ng bus. So ang mangyayari, magkakaroon siya ng fault. Then, yung fault sa bus, i-convert into Hilbert transform. Voltage deviation RJ. So, i-convert niya sa tatlo. So voltage deviation YJ and voltage deviation BJ. So, ito yung voltage, so transform voltage ng bus J. So R means red, Y yellow, and B blue. While yung J, yan yung bus. So yung RYB is color coding yan sa 3-phase system. So, classify the fault. Next is classify the fault by plotting the absolute and imaginary part of each phase. So, itong Hilbert transform is ginagamit siya for fault classification. So, next is identify all the connected lines to bus J. Then, ang next process niya ay take change in positive sequence current of all connected lines. So, apply the SPWD method to find the TFR in terms of spectra coefficient. So, next is summing the SC of all frequency present, evaluate total spectra coefficient TSC. Then the next is choose the maximum value. Then pag na-choose na yung maximum value, so mag-indicate mo siya ng fault line. Then magse-select na siya ng next segment. So next is meron tayong figure A and figure B. Yung A is block diagram ng data acquisition or mga sample signal. While yung B is yung kung paano mag-classify ng fault. So ito yung block diagram niya. So sa A, so data acquisition of sample signal Fs. So next is frequency, scaling, and wavelength covariant matrix. So, ang next na is power spectral density and its energy. And next na is threshold-based analysis. So, if threshold voltage is less than the fault voltage, so ibig sabihin wala siyang fault. So, if threshold voltage is less than if the fault voltage is less than threshold, ibig sabihin wala siyang fault. So, pag nagka-greater yung fault sa threshold, ibig sabihin meron siyang fault. So, eto yan. So, eto siya. Itong mean voltage deviation. MK must be less than 0.015. So, ito yung kanina. Then, fault accord mean voltage deviation MK is equal to max mean voltage deviation MK. So, ito na yung simplest explanation. So, yung fault, pag ang fault voltage ay mas malaki doon sa threshold, meaning magkakaroon siya ng fault. Pero pag less than yung fault voltage sa threshold, ibig sabihin wala. So, eto naman, yung sa B, is yung kung paano mag-classify na fault. So, compute PM using 7 and 9. Then, compute the helical distance with 10 and 11. So, ito yung mga number 7, ang mga number dyan is yung fault sa bus. While, the next is classification ng mga fault. So, kapag ang helical distance is less than 0.2, so 3-phase, so fault sa 3-phase, then pag helical distance is less than 0.2 and 0.3, so fault sa double phase. Then pag ang helical distance is greater than 0.3 but less than 0.4, double phase to ground. So yan yung pag-classify na ang fault using helical distance. So eto na yung explanation, so nakasulat. So in-interpret natin sa Tagalog. So in discussion number 3, so correct modeling of components and correct fault analysis in power generation and distribution are critical in ensuring safety and reliability of electrical system. This is fault analysis, electrical system. So one of these is fault analysis. So yung fault analysis, important consideration in power system planning, protection, equipment selection, and overall system reliability. So, in-explain dito yung importance ng fault analysis. So, the first and third researcher used real-time data acquisition, which aim to detect fault in real-time, fault analysis, and location fault in distribution network, which is one of the advanced way methodology in fault analysis. While the second researcher proposed a traditional but reliable method for detection using multiple faults, and yung second researcher uses a computation-based approach in fault analysis. So number 4, conclusion, detection of the fault location in transmission line is one of the vital concerns in power system. Different transient events such as fault, line switching, on and off heavy loads, generator disconnection do occur in power system. So that's why engineers conduct many studies to improve the following. Number 1 is reliability and accuracy of electrical system using smart and real-time fault detection. Number 2 is provide quick and accurate data to accelerate the repair and restoration of power supply. So number 3 is determine the short circuit and fault current using simulation to verify the adequacy of existing power system components as to whether they can withstand prospective short circuit event. So next is bibliography. So ito yung mga references na ginamit natin sa real-time fault analysis transmission line using wavelength multi-resolution analysis base frequency domain approach. Ito yung mga author niya. Next is detecting instant multiple fault on the transmission line and its type using time frequency analysis. Then the third reference natin is fault detection and classification in power transmission line based on transient signal.